proportional, aka same fractions, equivalent fractions, because that's really all something needs to be in order to be proportional. It means this fraction equals that fraction. That's what a proportion is. And so we're going to look at a bunch of examples and we're going to determine whether particular relationships are or are not proportional. So let's dive in and look at example 1, shall we? We get somewhere to write. There we go. So we're going to determine whether the cost of coffee is proportional to the number of pounds. Explain your reasoning. Okay, so what we need to know is if each one of these rates are the same. So this first one is kind of our baseline, right? It's 1 to 3. So does 2 to 6 equal 1 to 3? Yes, in fact, it does. It would help if I would write the number 3. Does 3 to 9 equal 1 to 3? Well, yes, it does. Does 4 to 12 equal 1 to 3? Well, 4 divided by 4 is 1, and 12 divided by 4 is 3. So this is proportional. Yes. And because this. They all have the same rate. Easy peasy, lemon squeezy. That's all that a relationship has to do to be proportional, is have a constant rate. Let's look at a second example. We're going to determine whether the number of miles is proportional to the number of hours and explain our reasoning. If you're good with reducing fractions, you may have already figured out that this one is not, but let's double prove it, right? So this first one is 1 to 50, right? Great. 2 to 70. What does 2 to 70 reduce to? That reduces to 1 to 35, which is not 1 to 50. What about 3 to 90? Well, that reduces to 1 to 30. What about 4 to 110? I don't even know. What is that? What does that reduce to? Let's see if I've got that on here. 4 to 110. Yeah, this one reduces to 2 to 55. So no way, no how. No. It is not proportional. Because it does not have a constant rate. Let's do one more. This one's got this last example's got kind of a little bit more meat on its bones, but it's not really that hard. And it may have a topic that you may be able to kind of actually figure out the answer already if you know a little bit about circles. So a circle's circumference is proportional to its diameter. So before I read any further, I'm going to kind of write a ratio there. So a circle's circumference is proportional to its diameter. Right? Makes sense so far? Okay. So the circle shown has a circumference of 12.56 meters. So its circumference is 12.56 meters. I'm putting units on there because we want to make sure that they match, right? We're going to write an equation relating the circumference of the circle to its diameter. So it gives us a diameter of 4. Diameter of 4 meters. The units do match. So we need to reduce this down. We're going to reduce this down to a unit rate. And this is the part where, if you know about circles, you might not be all that surprised to find out that this ends up equaling 3.14 to 1. There you go. What is that? That's pi. That's pi right there. It's pi. Well, at least part of pi. It's a rounded pi, right? So then we want to find out what the circumference would be if it has a 6-inch diameter, right? So we're going to have a proportion. We haven't really talked about solving proportions yet, but we're going to multiply it. The circumference equals 3.14 times 6. And when we do that, we end up with a circumference of 18.84. Don't forget those units. That'd be important. Man, these lessons are blowing by. This unit's got a lot of them, but like I said, from lesson, I struggle with those two words. If y'all notice that, I do. From lesson 1, the actual lessons and the actual content is not really that bad, even though there's a lot of stuff. If you're one of my students, I'll see you in class. Thanks for joining us on video. Thanks for watching this video. If you made it this far, thanks for making it a whole 6 minutes at this point. If you're not one of my students, thanks for joining us too. You're lovely. Check out emberlearninglabs.com for everything else. Don't forget to like, comment, and subscribe. We'll see you later. Bye-bye.